Hello, everyone out there from Puzzle of the Day, where learning is fun and entertaining. So, today we are going to talk about how to approach logical problems. We learn this with the help of an example, as this is the best way to learn. Again, focus is on the approach rather than the answer of the problem. As if you learn approach, you will be able to solve more problems yourself. Typical websites nowadays, they give you a puzzle and they give you the answer, but really, that doesn't help because knowing just the answer is only 1/10 of the problem. Knowing the approach is the thing that we need to focus on, and that's what this video is for. So let's talk about the problem. So our problem is you are given two ropes of non-uniform length. So let's make it a little bit like non-uniform so that it's easier to visualize. So you have given two non-uniform ropes. So the condition that you have been given is both of these ropes can burn exactly in 60 minutes. So what we need to do is we need to measure exactly 45 minutes of time using these two ropes. So the question is pretty clear. So now let's talk about how do we approach this problem, right? So bear in mind that you have been given 60 minutes of ropes and you have been asked to measure 45 minutes of time. So first of all, let's think about what is the relation between 60 minutes and 45 minutes. There has to be some relation. So one thing to notice is half of 60 minutes is 30, right? And another half of 60, another half of 30, or in other words, 1/4 of 60 is 15 minutes. And you can easily see if you add these two numbers, it gives you 45 minutes. So that's interesting. So that's something we can use. So I know I have a rope that burns completely in 60 minutes. So if I can double the speed of burning, it will burn exactly in 30 minutes. And if I can burn this rope with 4 times of actual speed, it will burn in exactly 15 minutes. So now the point is, how can I double the speed of burning? So one way of doubling the speed is I just slide both ends of this rope, and that way I kind of double the speed of burning, right? Which means rope would be burned in exactly 30 minutes. So now this seems very reasonable when the rope is not uniform. So if you see rope A, which is uniform, it seems to make sense. But if we have a not so uniform rope like this, how does it affect the timing, right? So we know this rope A, can burn in exactly 30 minutes. We want to see if the same is true for rope B. So let's deep dive into it. So I know if I'm given a uniform rope, if I light one end of it, so after exactly 30 minutes, it will reach the center, right? Because this is a uniform rope, so the speed of burning would be very uniform. So therefore, if I burn the other end, it will reach the center in exactly 30 minutes. So they both meet in 30 minutes time. So that way I can measure 30 minutes by lighting the both ends. But now in case of not uniform rope, so the rope is something like this. So now I know if I light one end from here, the other end from here. So I know if I light from one end, this rope after 30 minutes, it will burn up to certain. So let's say if this is the center, so it will pass the center because on the left side, I see a rope that has less content. So this will be burned in less than 30 minutes. Right? So which means at the end of the 30 minutes, if I light it from one end, it will reach somewhere here, right? Similarly, if I light the rope from the other end, it will not reach here because it'll this whole half gonna take more than 30 minutes, so it will reach somewhere here. So I know if I if I burn from both ends, it will be burned in exactly 30 minutes. So based on the density, the where they meet after 30 minutes, that point might be different. So now I can see that if I whether it's a uniform rope or not uniform rope, if I light both ends of it, right? So I know I can measure 30 minutes of time by burning two ends, right? So some part of problem is solved because we are now able to measure 30 minutes of time, whether the rope is uniform or not uniform. So now let's talk about how do we measure the remaining 15 minutes. Remember, we are given our problem is to solve and measure time 45 minutes, but we have been able to measure only 30 minutes as of now. So how do we measure 15 minutes? So let's go back. So I think we talked about that we can measure 15 minutes if we can burn the rope with 4 times of the speed. So one way of doing it with the 4 times of the speed is if I burn the rope from two ends as well as the center, so I know this part will be burned in 15 minutes, right? Because this is half the rope, right? And this part will again be burned in 15 minutes, right? So if I was given a non-uniform rope, I can easily measure 15 minutes, right? Which is the other part of the problem, that first I'll burn the rope A from both ends, and when this is done, I'll burn the other rope from both ends as well as center. So that way this would give me 15 minutes and this will give me 30 minutes, and if I add these two, I can measure 45 minutes. But I think our problem is our rope is not uniform. So if I were to measure 15 minutes, I know this is the center of the rope. So if I burn this end and I burn this end and I burn the center, I light the rope from the center. So I know now this part is going to finish in less than 15 minutes. Why? Because it has less content of the rope. Similarly, this part of rope is going to finish in more than 15 minutes, right? So I know now that I cannot measure 15 minutes because my rope is not uniform. So now what else can we do? Is there anything else we can do to measure 15 minutes? So one interesting part, we discussed that if we are given non-uniform rope, so we can always measure 30 minutes because if we burn from both ends, they may not meet at the center, right? But we can measure exactly the half time. So if I am given 60 minutes rope, uniform or not uniform, I can easily measure 30 minutes without any problems. But that's not true if I have to increase the speed 4 times. So that's something which I cannot do it, because in that case the left part of the rope would be burned in less than 15 minutes and the right part would be burned in more than 15 minutes. So now let's approach this problem from another angle. So how can I measure 15 minutes now? So I know if I was given a rope of 30 minutes time, now whether it's uniform or not uniform, I can easily measure 15 minutes, right? This is similar to what we did before, right? Because when we had 60 minutes rope, whether it's uniform or not uniform, if we burn from both ends, I can easily measure 30 minutes. So similarly, if I am given a 30-minute rope, I can easily measure 15 minutes without any problems, whether the rope is uniform or not uniform. But our problem is we have a non-uniform rope, but we have only the rope that can measure 60 minutes time. So can we make a rope that can be burnt in 30 minutes time? So that will ring some bell in your mind, right? So now what we can do is, so now let's go back to the original problem. So we have been given rope A and then rope B. So if I light this rope A from two ends, it will be finished burning in exactly 30 minutes. So what I'm going to do is, I'll light the first rope from two ends and the other rope from one end. So by end of 30 minutes, this rope would be burnt 30 minutes and it will have a remaining of 30 minutes. So which means if after end of 30 minutes, this rope is already burning, in the process of burning from this end, at that point I light the other end of this rope. Because the whole rope, the remaining rope was going to finish burning in 30 minutes, but now I light the other end, which is basically I double the speed of burning, it's gonna be finished burning in exactly half the time, which is 15 minutes. So that way I'll be able to measure my 30 minutes and 15 minutes time, which is 45 minutes, which was my original problem to solve. We hope you liked our video. If so, please like our page and also share with your friends. You can also go to facebook.com/puzzle of the day for our page where learning is fun and entertaining. Thank you. Have a great evening, everyone.